Hello guys, welcome back to my explanation video. Today we're going to explain about physics. The physics we're going to explain is momentum of inertia, Pascal, Archimedes, continuity, and Torricelli. Hello there, my name is Jahez Alaglanom, or you can call me by Hudan. I'm here as your explanation guru and explain all about physics. And today, first lesson is about momentum of inertia. Of inertia is a rotation of tor a point of torsion. A point of torsion is where you could see these three balls right here that has a different mass and had a connected rod, or this line is called the rod or whatever you call it, and it has a size, a length to each and between of these balls. So the question is, three balls are connected by a rod, as shown as the following picture, and the moment of inertia of the system whose axis is at point B is, so this is the point of point B. And the next step, as we're going to find, is finding the details of the balls. As we know, the rotation of A to B is 50 centimeters. And you can turn that 50 centimeters to meters. That is 0.5 meters. So centimeters to meters, right? Okay. And the next thing you're gonna do is find the mass of the ball C. The mass of ball C is 0.6 kilogram. So it's 0.6 kilogram. Next, we're going to find the rotation to B to C, that is 100 centimeters, yeah? 100 centimeters is 1 meter. Yeah, so we switch it up to a meter, because it's the rule. So if this is 50, and if this is 50, then 100 centimeters is 1 meter. So this like a half of it, Next is we're going to find the mass of ball B, that is 1 kilogram. Okay, next what you're going to do is write the formula down. The formula is the mass of ball A times the rotation of A to B square 2 plus mass ball C times the rotation B to C square 2 plus mass of ball B times rotation B to B times 2. So after you wrote those formula in, you're gonna put the data that you have collected from the balls, and then put it into the formula. So I forgot to put it. So the mass of ball A is 1.4 kilogram. There you go. So we're gonna put it in, and the mass of ball A is 1.4 times rotation A to B squared 2. So that's gonna be 0.5 squared 2 plus the mass of ball C is 0.6 times rotation B to C is 1. So you're going to put 1 squared 2 plus the mass of ball B is 1 times the rotation of ball rotation to B is of course 0, as we all know. square 2 equals, okay, so we're just gonna square 2 all of the numbers inside this. After you've done those, oh shit, you don't need the inside cave thingy. Next you're gonna do is just count them up. Well, you need a calculator for it, so hold on. Alright, once you calculate all this, it's going to be 0.35 times, sorry, plus 0.6 equals 0.95 kilograms per meter square 2. And there you have it. That's how you do momentum of inertia. Okay, what we have here is a Pascal question. So you might not see my writing very well, so I'm going to pop up the question in the screen in 3, 2, 1. Alright, so the question here is there's a car with a mass of 4,000 kilograms and it's getting lifted with a hydraulic jack with a lifting piston that has a cross section of 1,000 centimeters squared and a cross sectional area of the pressure pipe of 25 centimeters squared. The requirement of the force to lift the car is no there. That is the question of today's Pascal question. And here, imagine there's a hydraulic jack shaped like this, and then like there's a water
Hello, how
over
are you?
here. Okay, so what we needed to do is find the formula of Pascal. That is P1 equals P2. And if we turn it into the searching mode,
Huh?
like, and it's gonna be F1 per A1 equals F2 per A2. Sorry. Now we're going to put the detailed into the formula as usual. So the formula has gone like F1 per A1 equals F2 per A2. And as we can see here, the mass of a car is 1,000 kilograms. A mass of the car. So the mass of the car is the cross sectional, or so-called F2. So we're going to put it over into the formula. The F2 is 4,000, yes, per A2. Listen quickly. Listen. A2 with a hydraulic jack with a lifting piston that has a cross section of 1,000 centimeters square. So the cross section is over right here. It's A2, so we're going to put it on A2 equals F1. They don't have discovery about the F1, so we're going to just write F1 here and per A1. A1 is the cross-sectional area of the pressure pipe that is over right here, so we're going to put it 25 over there. Alright, we have here is the finishing formula that we're going to find out and count the formula. So we have 4,000 per 1,000. you can change this by dividing 4,000 and 1,000. What will it be? It's going to be 4. Yes. And what in the formula is doing is F1 times A2, A1 is times F2. So F1 times 0, there's nothing here because it's 4,000 already divided by 1,000, become 4, it's above over here. And 25 times 4. So the finishing formula will be F1 equals 25 times 4 equals F1 equals 100. And that is the final answer to the question of the Pascal. Next, we have a question about Archimedes. Archimedes is like a weight of an object or mass of an object is, inside water. It could be in the bottom of the water. It's floating in the water, or is it above the water surface, or it's like bloating, you know? Yeah. All right. So we have here is a question of Archimedes. I'm going to pop up the question in the screen in 3, 2, 1. Here it is. It is known that the weight of an object in the air is 15 N or 15 Newton. If the volume of the object is 1,000 centimeters cubed and the object is immersed in water, the weight of the object in the water becomes. So that is the question for Archimedes. So as we get to know of the question, we need to data the question. All right. We have here is an object is immersed in water. So we're going to write the formula first, right? Here we have the formula of Archimedes, that is Fa equals double omega in the air minus omega in the water. And in that formula we could change it into this, and it is raw water times gravity, that is G. Keep it in mind, gravity is always 10 millimeter per second squared, times the volume of the object equals the omega of an outside the water or in air minus the omega inside the water. With that formula, we could put the data of the question inside the formula. As we know, the omega outside the water is 15 Newton, 15 N, and the volume of the object is 1,000 centimeters cube. And what they need, or what they require, is the object inside the water. So the question is, inside the water is. Alright, after we data into the formula, we can get into the we could get into we can get into the counting. That is Fa. Put in the formula, and again, Fa raw water times gravity times the volume of the object equals omega outside the water, air minus omega inside the water, right? So keep in mind, the rho of the water is always 1,000. Always. Times the gravity, it is 10, yes, times the volume of the object. The volume of the object is 1,000, right? 1,000 centimeters a cube. It could change into 1 per 1,000, right? And then 1,000 goes up, so it's 1 times 1. Wait, 1 times 10, and then the top we get like minus cubed, like this, because the 0 has 3. If the 0 has like 4 or maybe more, like 7, you could add 7 over here, or 5, or the zeros, they are in the numbers, right? So we're going to put it like 1 times 10 minus cubed, alright, equals 15, because the omega outside the water is 15 Newton times omega inside the water. So we have here is 1,000 and 1,000, because 10 minus cubed is equals 1,000. So we could just get rid of that and then divide it, becomes 1. 1 times 1 is 1, so equals 10 times 1 equals 15 minus the omega inside the water. Alright, and then just count it in. 10 equals 15 minus omega inside the water, and then switch it up, the omega inside the water with the 10. So what we have is omega inside the water equals 15 minus 10. So the 10 switch into here, it becomes minus, right? So omega inside the water equals 5. There you go. And don't forget, it's always Newton, so we're going to put N. There we have it. That's the answer to the question for Archimedes. Next, we have a question about continuity. Here it is. I'm going to pop up the question in the screen at 3, 2, 1. Boom! There it is. If you guys can see. So, water flows from a pipe with a cross section of 25 centimeters squared to 5 centimeters squared. If the flow velocity at the large cross section is 2 meters per second, the flow velocity at the small cross section is. So we have here is an example of continuity question. So continuity is like a pipe, and there is a water coming through the pipe in a certain speed that could get into a larger, from a small pipe to a larger pipe, or it could go the opposite way, from like a small pipe to a large pipe to a smaller pipe. And here we're going to count the velocity, or how fast does the flow goes. First thing first, we're going to write the formula. The formula of continuity is Q1 equals Q2, and it turns into A1 times V1 equals A2 times V2. So we have here is the formula of continuity. So A is the cross section, the small cross section, and the A2 is the big cross section. Alright? V is just the velocity, the velocity of the water. So next we're going to do is to data in the question as usual. So A1 is 20. So the cross section, right, is the small cross section is 25 centimeters squared. The large cross section is 5 centimeters squared, and the velocity of the smaller velocity is 2 meters per second. So what we're finding is the V2, yes. Alright. Here we have the data in, and then now we're going to put it onto the formula. Alright, so this is the most basics. So this is the most basic thing. You just could put it into the formula and then count it as normal. So we're gonna put it 25 times V1 is 2 equals A1 is 5 times V2 is like that, right? And then we're just going to count it. 25 times 2 is 50 equals 5 times V2. So we switch it out and turn the V2 into the front and divide 50 with 5. So we're going to get V2 equals 10 meters per second. And there we have it. That's the question of Archimedes today. So next we have here is an example question of a Torricelli, or you could say water leaking from a bucket or glass or whatever you call it. And here we have another question, and I'm going to pop in the question to your screen in 3, 2, 1. If gravity, or g, equals 10 meters per second squared, the speed of the water coming out of the leak hole is. So we're going to find the speed of the water coming out from the hole. That's actually pretty useless in real life because we don't even count the speed of leaking hole coming out. What is the purpose of? Alright. As usual, we are going to data in the questions. Alright, here it is. The gravity is 10 meters per second squared, and the height of the water is height of water is 120 centimeters. All right, we have 120 centimeters, And the height of the hole is height of hole is 20 centimeters. All right. All right. So we have data in the questions, and then first thing first, we're going to find the quarrel of the height. All right. So what we're gonna do is just write height and put it in age something and put 120 minus 20 because the height will be uh, draining from the 20 centimeters, right? So it became 100 centimeters as usual. We're going to change centimeters to meters, so it's going to be 1 meter. All right. Next, we're going to put in the formula for the quarrel of the height of the water. So next, we're going to put the formula for the speed of water. The formula is V equals square root 2 times gravity times the height. All right, the quarrel of the height that we found, and then we're just gonna put it in the data. 2 times gravity. Remember, gravity is always 10 times the h is 1, the height. So we're going to put it. 2 times 10 is 20. 20 times 1 is 20. Right. V equals 2 square root of 5. That's the answer of the question for today's Torricelli question. And there you have it. Watching the explanation by the Indian ex-terrorist Jahazel Al, and I'll see you guys next time.